Hi guys, so today we're going to explain how negative pressure ventilation works, what a pneumothorax is, the role of a surfactant, and Laplace's law, the alveolar gas equation, and how oxygen and carbon dioxide are transported in the blood, including the oxygen hemoglobin dissociation curve, and what shift is. So, negative pressure ventilation. Normal breathing in human occurs through a process called negative pressure ventilation. This happens because the pressure inside the chest is made lower than the pressure in the atmosphere, which pulls air into the lungs. To understand how this works, we need to look at three structures: the chest wall, which naturally wants to spring outward, the lungs, which naturally want to recoil inward, and the pleural membrane, which includes the peritoneal pleura and the chest wall and the vertebral pleura on the lungs. So you can see all that here in this picture from our lovely textbook. Between these membranes, between the membranes is the pleural cavity. This contains a thin layer of fluid. The fluid creates surface tension that causes lungs to stick to the chest wall. Because of its attachment, when the chest expands, the lung expands with it. There are also several pressures that make ventilation possible. Atmospheric pressure, alveolar pressure, the interpleural pressure, and the transpulmonary pressure. During inspiration, the diaphragm contracts, which is what we see here. Just kidding. It's the same. The diaphragm tracts and move downwards while the external intercostal muscles lift, and the rib cage lifts the rib cage up and out. This increases the volume of the thoracic cavity. When volume increases, interpleural pressure becomes negative. The alveolar pressure falls below atmospheric pressure, and the air flows in. And when you breathe out, the muscles relax. So we're looking at this picture right here. Your diaphragm goes down, your rib cage go down, and it allows air to flow out passively. And then here we're going to talk about pneumothorax. Pneumothorax, it occurs when air enters into the pleural cavity, which you can see right here. This one says air leaks into lungs surrounding pleural space. This is from this is because this can happen when the pleural space, interpleural pressure, becomes less negative or even equal to the atmospheric pressure. That's what can cause this. Okay. Inside the alveolar, we have a thin layer of water, and that creates surface tension, and that allows the alveolus to get small or collapse. The more collapsing pressure, the smaller the alveolus, the smaller the collapsing pressure is. You can see that here and here. So now we're going to talk about Laplace's law. It's like the pressure needed. So it's like pressure equals 2 times surface tension divided by radius, which you see right here. This means the small alveolar requires more pressure, which we had already talked about. Alveolar gas exchange. We're talking about this specific equation is PaO2 equals PiO2 minus PaCO2 divided by R. Okay. This is inspired oxygen. This is inspired oxygen, arterial carbon dioxide, and this is respiratory exchange ratio, which is usually 0.8. This equation can help us determine hypoxemia and like hyperventilation, things like that. Transport of oxygen to carbon dioxide. 90% of it is bound to hemoglobin. 2% is dissolved in plasma. Right shift and left shift. I know I have it in here. Right here, okay. Left shift and right shift. Left shift is caused by proton, CO2, high temperature, and the 2,3-Bg factor. Yeah. That's the T state, just kidding, not left shift. Right shift, it decreases infinity. It increases the CO2, increases temperature, all that fun stuff. A left shift increases affinity. It decreases the CO2. It decreases temperature, decreases alkalosis, like hydrogens, which is decreasing alkalosis, and it decreases the 2,3-Bpg, fetal hemoglobin. Carbon dioxide is transported in 3 forms: bicarbonate, which is around 70%, hemoglobin, which is 20%, and plasma, 10%. For the 70 of bicarb, that one is, it turns to that. Then 20% binds to hemoglobin, and then 10% dissolves into plasma. Sweet. See you guys all in the next